Satellite communications is undergoing a profound disruption, says Kathleen Phillips, CEO of Tusk-IC. After Motorola's failure with the Iridium satellite network, the market barely moved for years. Until Elon Musk's Starlink changed the game. By dramatically lowering the cost of launching satellites into orbit, Starlink also has opened the door to a wave of new companies in the field. Tusk-IC is developing critical components for this new space economy. Chips that enable the transmission and reception of millimeter wave signals. And they are doing it in CMOS, the most widely used and cost-effective semiconductor technology. I sat down with CEO Kathleen Phillips and CTO Shailesh Kulkarni to discuss the opportunities they see. Kathleen and Shailesh, thanks for having me here in Antwerpen at the Tusk offices, Tusk-IC. Before we start, where are we? What kind of office is this?
We're in Antwerp, very close to the railway station, and this is the office of Tusk-IC. So this is where we have our designers doing our chips for satellite communication. It's an old residential building, in fact, so it's not a typical office, but we're very happy with the location and the accommodation as well. So today we have like 12 designers on board here in the office. We have a few people working in the lab as well, which is in Leuven still. We have a very exciting deadline, which is the evaluation of our first chips that have arrived, so a lot is happening.
Before we are going to talk about your products and technology, maybe you can explain or tell me something about the market that you're in. You make chips and antennas for satellite communication, and we know that Motorola already in the 90s had this adventure with satellite communication, Iridium, which went broke in '99. Then we had, well, a lot of years later, Elon Musk had a big success with Starlink, and now you're also into this market. You are developing chips for it, but maybe you can tell us something about the market.
It's a very interesting one because, as you mentioned, it's a market, you could say, that has been there for a while. It hardly moved until a few years back when Starlink entered it. And now it's in total disruption. It's a market that nobody has seen coming, not at this size, and it's a market that in fact is becoming consumer. So space used to be elite. It used to be like, you know, for the NASA and European Space Agency, but now we're taking the step where space becomes consumer, and that's what Starlink has done. And I would say that the pivoting moment is the fact that we have so many of these low orbit satellites being launched. So there's already 10,000 there in low orbit all across the planet.
And I think like 40,000.
Yeah, 50,000 by 2030 is going to be there. So it's the first time that you're going to have a communication infrastructure on a planetarian level. So think about it. So today we have base stations. They cover, you know, major parts of our countries, most parts of our countries, not entirely. But there's so many places where you don't have internet today, in the plane, on a boat, long-haul trains. It's going to be hard, or it is hard to have continuous work done, at least if you need online connectivity. Yeah?
One step back. Why, in your view, Elon Musk with Starlink has been able to grab such a big market?
It has been a very ambitious plan from the start, where he's solving the issue end-to-end, right? Starlink has the infrastructure there, so they are dominant on the space side with all the LEO satellites that they're having been launching. They have the launchers, the launch capacity, and they now also have brought the user terminals to the market at very affordable price points, both for launch capabilities. Their satellites, I don't know, but their terminals are very affordable. So suddenly this has become a mass market, which drives volumes. Volumes drive prices down, and that's where you go.
And you were talking about what prices?
So Starlink dishes, the small ones, are even you can buy them at $250 in Europe these days.
How much? $250?
Yes, US is a bit more expensive, but they're often also sold, or we assume they're being sold below actual cost, because what happens often in communication is, of course, that the subscription is actually making the return for the company behind it.
So SpaceX and Starlink has about 90%, well, the bigger portion of the market. There are a lot of companies developing, well, a handful of companies developing chips for satellite receivers. Why, can you tell me why Tusk-IC has a chance to enter this market, and how is this market developing? Why are there opportunities there?
Well, I would say we need competition, so there's definitely a concern on sovereignty, on supply, on the monopoly. So you see a lot of new constellations being launched, both in Europe. We have our IRIS² ambition, which is going to be there in 2030, but in any of the nations. So many countries and regions are installing their own satellite infrastructure. And they're going to need terminals that can connect to their infrastructure. Starlink is a closed system, so that will not interoperate.
Because Elon Musk sometimes behaves politically, and his Starlink project is a big factor actually globally in closing countries from his network or in opening it up. We've seen the war in Ukraine, which is highly dependent now on the Starlink receivers. Taiwan is not opened yet for Starlink, so that's really a bit of a political issue with China. China is developing their own infrastructure because they don't want to be dependent on Starlink. So you see an opportunity in open systems.
Oh, definitely. So I think long term, nobody's served by a closed system. Nobody wants to be locked in, let alone locked in the hands of one single man, in fact, in this case. So we need competition for many reasons. Second, I didn't get there yet, but also the band, the operational frequency band that Starlink is using is getting congested. So there's also a move to higher frequency bands with more capacity. So the success of these systems now requires that we start exploring higher frequency bands, and all these new constellations, they operate at what we call Ka bands, so higher frequencies with more capacity for users, higher data rate and so on. And that's also where we see an opportunity. Those chips are hardly around. So that's the right moment for us to enter this market, both from this need of additional supply and competition, as well as the need to explore new frequency bands.
Shailesh, you are one of the co-founders of Tusk-IC, I understand. And you are also the CTO, is that correct?
That's right.
So how did you end up in Leuven? Because that's where your Flemish or Belgian career started.
Right. So I'm originally from India. I came to Belgium more than a decade back. I came here to study initially, and then I ended up doing my PhD here. Our PhD was on millimeter wave, and we saw the market moving in that. We initially started the company mainly as a design service company, serving a lot of automotive clients.
Mm-hmm.
So
what did you design? What kind of chips?
So we contributed to circuits on automotive radar to large tier 1 companies. Those chips now are with the OEMs in volume. You could, if you want to build your own radars, you could just go and buy them. So we have contributed significantly to not just one, to multiple of those chips.
Mm-hmm. And what was the beginning of Tusk-IC? When did you see this opportunity to develop satellite receivers and chips?
This goes back a few years. As a circuits company, as RFIC company, we know very well how to design high frequency chips, and mainly in CMOS and silicon. We were first identifying the market. The market has to be big enough to create your impact. Back then, there was 5G millimeter wave, which was also under consideration.
It was 5G?
5G. No, 5G as the cellular.
5G, as in, okay.
5G, the FR2 band, the very popular. Many companies jumped on that. We also did consider it. However, after a careful monitoring of that situation, there was hesitation from network operators to actually roll it out. There are very few pockets right now where it is established, and a lot of companies attempted. But however, the challenge was mainly from the market side, and that did not pick up. So we right now, as of 2025, we do not see the kind of 5G FR2 rollout what was anticipated perhaps back in 2022. Looking back, that was the right choice for Tusk-IC. The adjacent market for us back then was satellite communication. Starlink was slowly ramping. They were...
What year?
This was 2021, 22. And we saw that as the right opportunity. If we now extrapolate, the impact what SATCOM can have is very massive.
What did you exactly see? You saw Starlink rising, they were getting to mass volume. And so what kind of opportunities did you see?
Before even Starlink, what was becoming much more evident, and this is before 2021 also, is the launch costs are really plummeting. They are going down and down. There are multiple new players, multiple new companies coming, and Starlink of course dominates that. The biggest entry barrier for SATCOM has been the launch cost. Mm-hmm. And Starlink has changed that with reusable rockets. Mm-hmm. And there are other companies also coming up with different strategies of lowering their launch cost. Mm-hmm. Once you enable cheaper, or relatively cheaper ability to put your payload in space, that's your entry point into enabling space infrastructure.
Yeah. But you're not targeting satellites, you're targeting receivers.
That's right. So we want to enable the ground segment of SATCOM.
The ground segment is the mass production of satellite dishes.
The ground segment is what is referred to as electronically steerable arrays. Traditionally, and going back decades, whenever we think of satellite communication, a giant metal dish comes into picture. Yeah. Still does an excellent job. However, a challenge with that is largely it is designed to look at one point in space.
Yeah. And all those satellites of Elon Musk, they travel in lower orbit and they move.
That's right.
That's the stuff, that's the thing.
Correct. So the term there is, it's called low Earth orbits, LEO, yeah. In short. Either you are static, but the satellite is moving. Yes. You need the ability to track it and look at it. Mm-hmm. Or other way around is the satellite can be stationary, like a geostationary satellite. Yeah. It's static. Once you, from Earth, you look at it, you have to look at one point. But then what if, and that's a use case enablement, what if you are on the move? If you, as in, if the ground station, the ground terminal is on move, it can mean you're in your car, trains, maritime, ships. Yeah. So that's another segment which needs flat panel arrays. The ability to look at either a moving satellite or yourself on the move.
Yeah. But can be moving both, isn't it?
And can be moving both, indeed.
Or is that an extra difficulty?
Not necessarily, not necessarily. The move part, the mobile part, means you have to first order move away from the metal dish type of antennas to what is now referred to as flat panel or electronically steerable antennas.
Yeah. You have this specialty, you have experts, a team of experts with microwave knowledge, analog chip design, and you saw this opening up of the market of satellite communication. So why did you think that you were able, with a small group, to enter a mass market? So what kind of what was there that you saw an opportunity to enter the market and be successful?
Firstly, it's our ability to do very optimized circuit design along with the market, the type of topologies of circuits which can enable these, and a path for volume. These all have to meet together. And that's it. So this kind of an opportunity coming at the right moment, and we trying to identify that back a few years back, so that now we come with the chips right now, what we have.
Yeah. And the Flemish or Belgians are known for their expertise in CMOS design
Yeah.
and analog, combining that. Before Tusk-IC, companies who brought image sensors to the market were very successful. Maybe you can explain me in a simple way what CMOS has for advantages, and why are you designing in CMOS? What is it?
CMOS is it's a very well-known recipe to enable very high volume. It enables you to have RF, analog, and definitely digital functionality. CMOS comes in a 300 millimeter wafer,
Yes.
which basically means we can pack a lot more chips on one wafer compared to a silicon germanium wafer, which is a 200 millimeter wafer.
Or other types of
semiconductor 3.5.
components. So it's basically a very cheap recipe to produce chips.
Cheap, yes, but from design point of view, equally challenging. So for example, a 3.5 wafer is perhaps even a smaller wafer, 6-inch wafer. Great performance, extremely expensive. And on the other side, you have CMOS, which is comparatively much cheaper, challenging to design, but then that is what enables you to go to volume.
Yeah, but so it enables you to go to volume, make cheaper chips, but it is hard to get the right quality. Because for applications like defense, you see a lot of 3.5 components, gallium arsenide, and
that's true. So that's where we have identified the right system partitioning of the chips, which part of the circuits goes in which part of the technology.
Okay, so you do use other semiconductor material.
We work with multiple fabs, so we have different chips in different fabs.
Okay.
Each identified for the right cost performance benefit.
So Shailesh, we have a lot of stuff on the table. Maybe you can show us how, what are really your products and how is it built into satellite receivers? What do we see here?
So this is a small receive Ka-band antenna array, electronically steerable antenna array.
Is this the size of a panel you would normally buy in a shop, or is it much larger?
They come in various form factors. So this is, let's say, on the low side, on the small side. With this, it should be able to enable about tens of megabit per second of data rate. However, what we are trying to build are, as you can see, there is one board which is on the bottom, and then you see these kind of modules which are stuck on a much on the smaller modules which are stuck on a bigger one. What we are trying to develop is, if I can show you this, so these are small modules. We refer to them as connectiles.
Yeah.
This is a receive module.
Yeah.
And this one, the smaller one, is a transmit module.
So why is the first one or the second one smaller?
Yeah.
Why is there a difference in size?
So broadly, the receive operates at around 20 gigahertz,
Yes.
and the transmit operates around 30 gigahertz. The size of those two, electrically, they are at the same distance. So each antennas are spaced roughly half a lambda apart. And it's because of the frequency difference, the size difference.
Maybe you can explain us why you need an array. Why is there so much dots why is there a matrix of antennas?
So an array, a single antenna, we could even consider an isotropic antenna. It's like it's like a light bulb. The light illuminates in a spherical fashion. But however, the moment you bring multiple sources at the right distance, they can constructively or destructively interfere and create a particular pattern. And when multiple of these antennas work in cohesion, you can direct the beam in a particular direction.
Yeah, you steer the beam.
You steer the beam.
And you do transmission in that way, and you do receiving in that way.
Precisely.
And you not only make antenna chips, so what we see here are the antenna chips, visible I guess.
Yeah.
So what is behind it? You also design back end of the receiver.
Yes. So the antenna part is one part of the story, but the more interesting part is what happens on the backside. So we offer as products these connectiles for transmit and receive. Behind each of the transmit, there is a transmit beamforming IC. So this is a test board, right? I just borrowed it from our lab. It's an 8-channel transmit beamformer IC.
Yeah, it's a test board. Yeah, it's just to test how the chip functions and if it functions well. So these PCBs won't end up in the final product. Only the chips that you see end up on the back of the antenna arrays.
That's right. So this is what we call a characterization board. We measure, validate, and test the chip as it is intended to perform. A similar chip is a receive beamformer. We have populated the connector, so I just borrowed it from the lab. Along with that, we also have a low noise amplifier. So this is the partitioning we have enabled to achieve the right performance and cost mix.
All right. Can you say show me again? So that's the receiver chip.
This is a receive beamformer chip.
Okay.
And
that's the
this is a receive low noise amplifier. The receive comes together. They are going to sit on this receive connectile. For the transmit connectile is going to use only the transmit beamformer because we can achieve the required output power requirements in this particular technology.
And you do the receiving and the transmission with the same antenna array?
No, so the transmit and maybe the receive arrays are going to sit side by side to enable simultaneous transmit and receive communication.
And you do that, and that's integrated in the same panel?
Eventually they will...
It works at a different frequency?
That's right. So they are going to sit on... That depends on our customers, the way they want to integrate, what form factor they want to enable.
So the one is around 20 gigahertz and the other one is around 30 gigahertz. Can you explain why this technology is now accessible?
Traditionally, and we have to go a couple of decades back then, RF has been in existence. It's just that RF CMOS is a relatively newer entrant, perhaps a decade, I would say.
But why can RF CMOS reach tens of gigahertz?
The technology is getting much better. The FT and Fmax of these go in hundreds of gigahertz. So with that, what that basically means is we can achieve enough gain from a transistor at 30, 60, 80 gigahertz.
And it's not dependent on high-end chip technology. You don't need a 3 nanometer fab for that.
No, in fact, 3 nanometer transistor perhaps might have a very high FT, but however, to access to that, access to the transistor, you are going to lose a lot of performance in those extremely thin metals which reach that transistor.
What kind of factories will your chips be produced?
These are going to be produced in commercial, very high volume factories like TSMC.
And what kind of nodes is it produced?
I would prefer not to comment on that.
How is it possible that a team of 12 designers can make 3 chips designs for a mass market and compete with a company like Starlink?
So these are prototype chips, right? So we still have a few steps to take, and we're also gonna double already like in next year. So we're gonna obviously increase the size of the company. But indeed, it's great to have already these prototypes done and in the lab and operational as we speak, right? So they're good enough to do pilots. to get feedback from early customers and then to take the next step and go for an actual product in mass volume.
So, what is the status at the moment? At the moment you have a bunch of 3 actually test chips, isn't it?
Yeah, prototype, pre-production chips, yes.
So what will be the work for the coming months and year?
So coming months is further evaluation of these chips, also in customers' product. So like in a pilot of the customer product, which would be a similar array where we put our chips in the way they wanted to use them. I expect we're going to get feedback, bells and whistles. They want to add improvements on some of the performance aspects. And that's the input for our next design cycle, which is going to happen over summer. That's going to be a next tape out. And that is kind of the samples that will need to go in production the year after.
Your chips are designed into an ESA project, I understand.
Yeah. So we've had sponsorship from ESA already for a few years. The chips were initially also designed per request of ESA because they see the need for European supply of such chips. Yeah. Especially also in K-band, nothing is around there today.
And is that connected to commercial initiatives? Because ESA is heavily subsidized. Is this has ESA connection to commercial parties?
So definitely. So the request is there in the context of the launch of the European constellation. So there's a lot of investment and even already private tender to manufacture and launch the European constellation. Same thing is now going to happen on the ground side, where there needs to be a European terminal that serves European governments and defense in connecting to the satellites. And that's where ESA and Europe wants to have domestic supply.
Because there are like several parties. There's Italian players, an Italian player, there's a Spanish player who wants to launch satellites. And are these companies also starting to sell dishes then in the future?
Depends which companies you're exactly referring to. So some of the companies are simply space players, others are indeed more vertically or hybrid, I would say, hybrid focused. Often they collaborate with antenna manufacturers. So for instance, if you would look at OneWeb, Eutelsat website, they operate the satellites, the constellation. You can get a subscription with them, but they will offer you a choice of a terminal from Intellian, from their own brand, Kaimita, whatever.
How do you expect that this market will develop? Will we be seeing strong players like Starlink all over the world? Because China is of course going to develop their own system. Even your chips might be ending up in Chinese products maybe, or African or whatever.
So Satcom is going to be a global business, that's clear. So on one hand you have the vertical players, our Starlink, also Amazon. So Amazon is going to be the next big consumer-focused Satcom player. There is also Starwin in China that has the terminals. They're also much more consumer-focused. That's going to be the low-end mass volume. Then in the adjacent markets, which are the professional markets, for instance, terminals integrated in an airplane. That's actually really integrated in the fabric of an airplane. The same can happen to trucks, cars, campers, emergency vehicles. Those are going to be different players. They need higher quality, higher capacity, and you have a lot in between that. So those are extremes, you have a lot in between that.
Are this kind of dishes already installed in airplanes? Because you now can have internet in an airplane.
Yeah, they're being installed. Yeah.
Okay, and they are from, not all Starlink, are they from?
Starlink is gaining market traction also in aviation. For instance, I believe they supply to Air France, but you also have Panasonic Aviation, you have Viasat. So you have multiple players there that supply this to aircrafts. Ka-band is still coming up.
Yeah, but these are still quite expensive dishes.
Yeah, and I think that's also affordable, allowed in comparison to the plane. But of course, if you go to private jets, or the planes also come in shapes and sizes.
Because for the Starlink dishes, you're talking about hundreds of euros or dollars. These very specialized receivers, they are $10,000, I guess.
Yeah, for planes probably even much higher. But for instance, if you would be a boat owner, I'm not, but you hear a lot of private people have a boat, they buy a Starlink dish. If you go to the commercial or the professional Starlink market already, it is already 2,000. If you go to competitors that may give you different plans and options, it easily is 10,000 and higher. Plain terminals probably still higher.
What is your vision for the future? How do you think the market will develop? The pricing will it come down very soon, or will it take many years?
So there are different segments, right? So on one hand you have consumer, and definitely market is only just getting started. Imagine half of the world, 3 billion people don't have internet access yet. And some of them become more wealthy, and obviously they want to be on the internet. That's consumer. And then you have all these applications and use cases that are not connected yet, that may be professional. For instance, if you have an oil rig, you want to have live streams continuously, no matter where it is. If you you operate a trucking company, you also want to have broadband on that truck, regardless of where it's driving. Remote regions. At my home, I still have issues with cellular coverage, and you have a lot of blank spots in our countries, in Germany, in France, in our countries. So it comes in all shapes and sizes. So it's as broad a market as any of the other connectivity markets, I would say, and maybe even more diverse than cellular, because the phone is very similar across each and every platform. While this comes, as said, it can be a man pack integrated in a backpack of a soldier, for instance. It can come as something integrated in the roof of your car. It can be integrated in planes. It comes as a standalone dish, anything.
So the world will definitely be less dependent on Starlink.
Well, that's why we're here, right? So yes, I think that's not a sustainable situation. Starlink is dominant. They're going to be around and dominant for quite a while, but there needs to be competition. It's too critical an infrastructure to not have any competition there.
And what is quite a while? Is that years, 1 year, or many years?
Well, there is already competition, but not on the same scale. So the next contender in consumer is definitely going to be Amazon. Let's see how they pick up.
And how have they formed their ecosystem?
It's fully integrated. They even have established their own manufacturing facilities to actually do the board manufacturing, let alone assembly, design. Everything is fully integrated and locked into one supplier.
But they, of course, source the chips from other companies.
Yeah.
They even have their own designers.
Yeah.
So they're in competition with you.
I don't think we're competing for the consumer market at present. We're competing for the higher end markets where you need higher capacity, higher data rates, higher reliability, higher performance.
But once you've reached that point, you can make your chips ready for the consumer market, isn't it?
Yes.
CMOS.
Yeah, definitely. Yeah, so that's the beauty of CMOS. So once you have reached that market point, that proof point of value, performance, you're an established player, CMOS has the advantage that you can scale up, and none of the other technologies can go to those volumes, and definitely not at the price point.
Can you elaborate on the competitive landscape? Because you see a lot of players like startups, but you also see these big chip companies like NXP or Texas Instruments. So who develops what kind of chips? How does this competitive landscape look like?
In fact, there are not so many players on the chip side. So historically, space was a niche market. It was slow, very low volume. It was, you deliver to NASA or a government. But it has never been a good match with semicon players, as you named them. The ones that do operate there are the ones that have been depending a lot on military contracts and are not very used to scaling up to the volumes that we see now.
So that's Texas Instruments, analog devices maybe, I don't know.
So, well, I would say on the classic semiconductors, they haven't been very active in space. The ones that were is like indeed analog devices, Corvo. And a few military branded companies, but there's not many. So this kind of falls between the very CMOS mass volume focused semis and the ones that were focused on space and specialty. It's a gap in between. Space specialty is suddenly becoming a mass market, but the mass market players have never played in space. That's the gap we try to fill.
But for them, this market is also attractive, I guess.
Sure, it can be attractive. So, but they're probably also only going to take that step once the volumes are actually established. So that's also a bit of the timing. that comes in. Many of the companies would only step in once the actual volumes are there. And then it's for scale-ups as us to kind of disrupt and make that happen, bring it to a certain volume.
What do you foresee coming for Tusk-IC in the coming years? What kind of milestones are you targeting?
The earliest milestones are early next year, where we are going to have pilots together with customers. That's very important. So
customers, more customers.
Yeah. As it looks now, yes. So that's going to be very rewarding. First of all, you get feedback, you start seeing the chip coming live in a meaningful application, so that's definitely a big milestone. Then we have our second tape out, and after that we actually are going to ramp up towards production, which is obviously a big adventure. That means that by the time you have orders in volume.
And when do you expect that?
So the volume and the shipment needs to come in 2027.
2027.
Correct,
okay.
Yeah.
That's all. So when the big semiconductor market is expected to pick up again, maybe somewhat later, but...
Yeah, well, in this case, let's look at the rollout of Ka-band services. Yeah. So we mentioned that we are moving to a higher frequency band, right? So today's operations are in the low frequency band. Yeah. The high frequency band comes in operation as of 2028.
Okay, so when everybody wants to get ready for that.
Yeah.
So you should have your chips ready for...
Exactly, and that's why these companies already want to start doing pilots, because they also want to show something to their customers, right? So the ball now starts rolling. Timing is as perfect as it gets.
Now, you've been working in the Netherlands for about 30 years. You've worked at the Philips NatLab. You were a managing director of Holst. Why did you choose to be CEO of Tusk-IC?
So I've had amazing time in the Netherlands with the companies that you named. So massive playing ground, lots of opportunity, lots of an impressive network that I was able to build up. But I wanted to take the next step, right? So I've been smelling at many different technologies. Taking the next step and actually making that impact in the market was a very nice challenge that came along. And I've had the privilege, as you named, to work in IME call center at the time, from basically the foundation all the way to where I left it, so over 200 people there. And that has been a very rewarding experience, so I hope to do that again here with the same bright people in a new context.
How did your environment or your working environment change? Switching from managing hundreds of researchers at really research institutes and ending up in such a small team.
Yeah. So organizationally, of course, it's day and night difference. As you named it, a big team, a small team, a big organization, everything arranged for you versus a small company where everyone does everything. But at the heart, a few ingredients remain the same. It's very bright people. It's extremely impressive technology and capabilities. Working at the forefront of new markets, so also that part remained. The network also remains the same, so the external network is very useful. Also come to experience that since you're limited within your own company, you reach out much more to peers in the industry. So that connection becomes so much simpler. So your network is a lot also outside of the company. So there's a very good dynamic between the various scale-ups in the region, the various suppliers. You know each other, you help out on small and bigger issues, and that helps. So in that sense, it's also a large fabric that we have in the ecosystem, and you should also make use of that, even if it's not within your own company.
Tusk-IC raised venture capital. Can you tell me something about your financial status and roadmap? Because you for the production, of course, and making masks in fabs, you probably need a lot of money. I don't know how much that is, but what are you looking at?
Yeah. No, it's a good question. So of course, if you are ambitious, you need money to execute on that ambition. So far our funding especially came from ESA and two VCs, so that is established. We're now heading towards a closure of a next capital round, with a lot of interest in fact. So we expect that to close in February-March timeframe. And that's when we can start scaling up team size, profiles, and take the next steps. Also, these pilots, of course, take resources.
Yeah, for the next round, how much money do you need?
Or we'll publish what we when we get there. I will let you know. No, it's of course it's significant. Of course, deep tech is always significant. But then, of course, it also scales in the volume. That's you go to the millions of chips per year. Yeah. So there is a serious NRE investment, but of course also a multiple of that coming back in return. Once you're in volume.
So how does a life of a CTO of a chip design company look like? How do you spend your week?
Yeah, one is most important is discussions with the team, keeping a track of what's going on, what are the important topics which needs attention. There are always surprises which come, and then you have to be not necessarily in a firefighting mode, but prioritize and a lot of delegation, and teams are very agile. They pick up topics, very impressed with the team, the kind of different topics they address on, let's say, on a monthly basis. It can be from a specific programming or a circuit topic on one end to the other side being something with working directly with the suppliers.
Do you have a sort of system architecting role or a system engineering role? You don't do chip design yourself anymore.
I would like to, but I don't have the time for it. But on a weekly basis, it could be you sometimes work on a very zoomed out role, and other day could be very zoomed in role looking at a particular transistor or a layout. So both can happen in the same week.
Yeah, but do you feel you are an architect?
Taking more and more role on the architect side. Yes.
And what does it mean to be an architect for this kind of systems? What kind of decisions have to be taken if you design these kind of systems?
I think I work also very closely with the customers. Most important part there is to listen to them. What are the pain points? What exactly are they trying to achieve? Because those kind of talks and those kind of interactions trickle down on the chip architecture, on the partitioning, on the cost structures, and then it trickles down to what kind of performance we can achieve.
Yeah, but for an outsider it's very difficult to understand that, because you have the specs, you have the 20 gigahertz and 30 gigahertz, and then you have the specs, it's already known.
Yeah.
There's standards who have been agreed. So why is this so? Why is listening to customers so important? Why do you need their input? You already know the specs of the system, don't you?
Yes and no. Like Kathleen was mentioning, there is no one use case. They can happen in different form factors. Mm-hmm. It can be a very small portable to a very high performance large array. Yeah. They both are trying to, the chips what we design should be able to serve both those needs. Mm-hmm. So for someone, low power is essential. We need to enable low power features on the chip. Yeah. On the other side, for someone doing very large arrays for very niche applications, it could be, for example, thermal is a problem, thermal challenges.
Yeah. This is important because you don't want to make two separate designs. You actually want to make as less designs as possible.
We want to enable different customers to build their systems. If it means we can capture them in a same chip and same architecture, that's great. Yeah. If not, we will consider multiple product families. But
if the series are smaller, then it'll be more expensive.
Yeah, so that's the kind of strategic decisions we take internally in the management. Yeah.
And is that also brought into the negotiations with the customer? Like, for instance, you can say to a customer, well, if you want this special topic, then your chips will be more expensive. But if you downgrade your functionality, I can make it cheaper for you. Or you put some more water in the wine, and
it's about understanding what market, what segment they are trying to solve, right? I mean, cost is one discussion, but it's one part of the discussion.
Is cost not so big an issue because you don't enter the consumer market yet?
No, cost is always an issue. It's an important parameter, but along with it, what other areas of importance are they trying to solve? Starlink is trying to address one segment, which is consumer, very aggressively, but there are also many other applications which needs slightly different features on the chip compared to the consumer.
Yeah.
And we need to understand that complete landscape.
If you look at CMOS sensors, if we talk like 20 or 30 years ago, everybody said to me, CMOS sensors cannot compete with CCDs.
Mm-hmm.
And so CCDs will always be outperform CMOS because, and then of course they said, well, this the pixel, the size of the pixels and the photos, you had this quality story. But now you see CMOS sensors, for instance, in these Sony's cameras, and they are so sensitive and they're so good that they easily can compete with CCDs. Is such a thing also that companies will underestimate the power of CMOS?
It depends. CMOS is a great technology. It enables you to bring a lot of features. It can compete in a very, it can give great performance in large segments of the spectrum. Having said that, it is, if you pit it directly against a 3.5 technology, it cannot, for example, deliver kilowatts of RF power, right? So that is not a playground for CMOS. CMOS's strength is you have to evaluate it against its own strength, and for example 3.5 against its own strength.
It depends on the market. You cannot compare it. You have to compare what kind of functionality you need, and that's much different in an image sensor market than in a transceiver market, where 3.5 components differ quite a lot from what you can get from CMOS.
3.5 definitely has its share in, let's say, the RF spectrum. It's a great technology, but perhaps not for these applications.
So you will see that your systems will end up in a lot of applications. Like do you envision, for instance, that a fleet of a truck fleet will be like logistics companies and truck companies will probably be using your panels to steer their fleets?
That's a possibility, yeah. We should not rule that out. But for example, to get, maybe if we put it in let's say a dual case use, possibly, let's say there is a drone which needs to stream live feed, and that is then possible using SATCOM. That's a use case. You can also extend that on terrestrial, for example, a trucking company, emergency systems in remote regions. If they have to establish high bandwidth connectivity, it is then possible.
Yeah. So you'd also be able to use these systems on drones?
Yes, yeah. Light enough and low power enough.
And low power enough.
Yeah.
Don't have to have big battery packs to store
Right.
this.
Yeah. Power is of essence.
So you were in a quite safe environment, yeah, working for as a researcher. Was it a big step to decide to start a company and work more entrepreneurial?
Sometimes you should not overthink everything. Risk becomes a risk when you actually think too much about it. You have to just get going, get executed. If you fail, okay, tough luck. Get up next day and start to solve things again, and that's it. It's,
So what's the fun of your work?
There is never a boring day.
Never boring.
Never a boring day. There is always something new to solve, technically, team-wise, customers, suppliers. There is always something, and that's what makes the day exciting.
Yeah. And why is working in Belgium an advantage for such a company?
Firstly, the location. I think Belgium is very well located geographically. It is the capital of EU. A lot of interesting discussions pass through Belgium in a way, so that we are at the epicenter here.
Yeah. And do you have access to expertise, to advice, business-wise or technology-wise? How does your network look like?
Yeah, we get great support from access to Foundry through local partners here, access to from supplier side also. So it's in that form we are very well connected.
So Belgium is attractive from a technology standpoint, but what about the satellite community? There's also a lot of companies working in the space area, isn't it?
That's true. So being based in Belgium, we are very close to some of the modem builders, some of the system integrators in France and in Germany also. So that from vicinity point of view, we are close to our customers, and that enables us to understand their requirements much better.
Okay. So how often do you spend at customers?
That comes in waves, but sometimes it's like multiple calls in a week. We have that. We trying to understand, and then sometimes we go back and try to go back on a drawing board, trying to drill down that kind of requirement all the way down to the chip, what that means. And we also have quite some systems engineering, so we have, in a way, try to solve our customers' problems or build, maybe not in the full scale, but also build what exactly they want, so that we understand firsthand what that means, that particular problem.
What is their biggest issue? What's their most important demand? What keeps them awake at night?
Getting the right performance, I would say. Getting the right performance out of, it can either be constrained from power or cost or form factor. So these are getting the right performance in a given constraint.
Kathleen and Shailesh, thanks for having me in Antwerp.
Thank you for joining us here.
Pleasure to host you.
With the company. Hope you will reach your milestones.
Thank you very much.
You will.
Of
Yeah.
course.
Thanks for listening to my interview with Kathleen Phillips and Shailesh Kulkarni. If you found this conversation insightful, make sure you subscribe to the Bits&Chips podcast. By subscribing, you'll automatically be notified when we publish new interviews and upcoming editions. And if you'd like to help us reach a wider audience, please give this episode a like. It really makes a difference. In the coming weeks, we'll publish interviews with Maarten Bonnema of the University of Twente and Arie den Boef of ASML. Thanks again for listening. I hope you'll join us next time.